Okay, so converge or diverge. If converge, find the sum. You want to be looking for those instructions. So if it says find the sum, then you're going to want to find out if it's a geometric sum, because if it's geometric, then you can actually find the sum. So we could leave things like this and just go plug in n equal 1, 2, 3, and 4. I'm sorry, n equal 1, n equal 2, and n equal 3, and then play with the exponents as we go along. So if I plug in n equal 1, I get 3 to the 0 power, and plug in n equal 1 times 5 to the 0 power, so that gives me the number 1. All right, let's go plug in n equal 2. So if I plug in n equal 2, I get 3 to the 1 power. And then if I plug in n equal 2, I get negative 2 plus 1. I have 5 to the negative 1. So this is the same as saying 3/5. If I plug in n equals 3, I get 3 squared. And then 5 to the negative 2. So this is the same thing as saying 3 squared over 5 squared. So a is equal to 1. Right? That's always the first term. AR is the second term. AR squared is the third term. So it looks like R is 3/5. So let's just make sure we didn't make a mistake. If I multiply this times 3/5, do I get this? I do. So this converges, and the sum is A over 1 minus R. Okay. C or D, if C, find the sum. So if I go and plug in n equal 1, n equal 2, n equal 3. n equal 1, I get 3 to the nth root, the 1th root, or the first root, so that's just 3, plus 3 over the square root of 3, because that's what this nth root, square root, 3 over the cube root of 3. Wait a minute, this is not geometric, is it? It's not a geometric sum because I don't have a common ratio. Oh, I recognize this. This, remember, because we're learning and kind of adding on to what we know, that's not p-test. This is that nth root. This is the problem that we do the test for divergence on. Because when I take this limit, and I put infinity up here, I get 0, so I get 3 to the 0 power, which is 1, so I get 3. And remember, the test for divergence says if it doesn't equal 0, then I have diverge by T for D. So this is one you're just going to need to recognize. Oh my, look at all these things. Okay, so this is one term, those are all multiplied, and this is another term. Again, to find a common ratio, I'm going to need to separate, if there's addition, into two separate sums. So let's take the time to do that. 5 to the negative 2n, negative 3, and that's 1 to infinity. And then 1 to infinity, 3 to the negative 3n. Okay, so you've seen me not play with exponents. We could do a little bit of playing with exponents on this one. I'm going to leave this negative 3 to the n plus 1 up here, and I'm going to pull this to the denominator, and I'm going to make it 25 to the n. And I'll do a little bit of fixing here. Negative exponent. I'll put it in the denominator, and that'll be 27 to the n, right? That's cubed to the nth power. All right, so go plugging in n equal 1, 2, and 3. You're getting the idea now. So when I plug in 1, I get negative 3 squared over 25. And then the next term will be negative 3 cubed over 25 squared. Negative 3 to the 4th over 25 cubed. So my A is negative 3 over 25. And my my A is 9, right? Or I'll just leave it as 3 squared, right? Because taking negative 3 and square it, I get my A. My R is going to be negative 3 over 25. The absolute value of R is less than 1, So this converges. So the sum from here will be A. So I'll make it 9 over 25 over 1 minus my R. So that's going to turn into a positive sign. So that's the sum from this one, right? And then from here, I can see that my A is going to be 1 over 27, and my R is going to be 1 over 27. That's a pretty easy one to see, yes? So my A over 1 minus R. So this is the sum of these two separate sums.